Okay, so we've been looking at graphs and of functions to talk about its first derivative, and graphs of first derivatives to talk about the function, and then we started talking about doing a first derivative test. And recently we've been talking about not only the graphs of f and f prime, but we slightly started talking about f double prime and how that can help us with the graph of f. And this brings us to doing what is called the second derivative test. So you already know the first derivative test, and that we developed a procedure that outlines what's needed to be done from steps A through H, okay? So we're going to continue off of the first derivative test to do the second derivative test, okay? So that means that the second derivative test continues. We still have to do A through H, but now we have I, J, K, L, M, N, O, P. All right, and then we're done. So copy this down, and I'm going to pull up the other slide so you get all of the steps. Make sure that this procedure is in your notebook. Okay, so here we have it. And as you start to look at some of these, like I, J, and K, it's very similar to when we were taking f prime of x. Now we're finding f double prime. We're taking f double prime of x to see where it's not defined. So that talks about f prime being not differentiable. K, taking f double prime setting equals 0. And these are to find possible inflection points. So that gives us some more critical points to kind of check. And then we have LMN and LMN. We end up doing another chart, but this time to talk about the concavity of F. Okay, and we do that from determining the sign of F double prime, and it also can tell us if there are any inflection points. Okay, so always to just write out your answer for SAT talking about the inflection points. And P is to make sure you answer all of the questions. So if you look back and you realize, oh my goodness, I never answered where F was increasing, or if it isn't F of X, it's just Y, where Y was increasing or decreasing. They asked for not only where there's inflection points, I forgot to write down intervals where it's concave up or concave down. So that's why we have P. Sometimes they ask you to sketch, which we saw in the last lesson. We can possibly do a sketch. But each problem is a little bit different, so always just take what you're learning from your lessons and try to apply it when you see all different various problems. So speaking of various problems, we have here an example. Of course we do. Find the points at which f has a local max, a local min, and a point of inflection, given that y prime is the quantity of x minus 1 squared times the quantity of x minus 2. Okay, so given that y prime is continuous and differentiable, okay, for all x, okay, then y is continuous and differentiable for all x. Okay. Actually, you don't have to say about this differentiability, but we want to state about the continuity. So differentiability implies continuity. So seeing that we do have a derivative where there's no place that's undefined, we know that our original function is continuous for all x. Okay, this is actually A. So B, find the first derivative which is given, or I can just state that it's given. It's nice and easy. C is to look where it's not defined, and we kind of said already that it's y prime is defined for all values of x. So y is differentiable. I erased that part. For all values of x. Okay, D. So we're not getting any critical points here for our first derivative test, but we can take our factors and set them equal to 0 and solve. Okay, and we find where x is 1 and 2. There are critical points, also called critical numbers. So now we're going to create our table for f dt. I wanted to make a room, so intervals of x negative infinity to 1, 1 to 2, 2 to infinity. Okay, so if there's 2 critical numbers, then there's 3 intervals. Next is the sign of y prime. If you want to say f prime or f prime of x, then state that you're talking about this right here as f prime of x. But here we go. So if I choose, let's say, 0, I'm getting a negative answer. And if I choose, let's say, 1.5, then I'm getting a negative answer. And if I choose, let's say, 3, I'm getting a positive answer. And so the behavior of y would be that it's decreasing, decreasing, increasing. So h, okay, I can state that y has a relative min, okay, because, I don't want to say f because I was using y's, because y prime changes sign from negative to positive. Okay, and now we have to do I, because we're really supposed to continue if they ask for points of inflection. So there, it turns out that there's no local max. So if you want, you can state that there, or we could put that in part P. Okay, it doesn't make a difference. So like I said, let's continue. So part I, we want to look at y prime and see if this is continuous. J, we want to see what y double prime is. And so we can use product rule here. And our first derivative of the second plus second times the derivative of the first. Okay, and we can see that we have another polynomial function. So we can say, okay, that y double prime is defined for all x. So y prime is differentiable for all x. So we're up to our new chart. So I'm going to erase this other one to do LMN. I just realized I kind of added a step here, so I'm going to explain what I did when I added an extra step. I was just being very, very thorough, so just bear with me. So we need to find f double prime of x, and so I just restated this here, which I already kind of said before. So f double prime of x was really I, and then j is here, and then k is where I have to set your y double prime equal to 0. So before I get to a new table, I want to make sure that I have you correct the letters in the right places, okay? So this is like I, and this is just extra. All right? Please just correct that. I'm sorry. I got too excited when I was doing the problem. Wouldn't you be? All right, so this is I. This is J, and we're up to K. So we have to take a look at our polynomial function. So y double prime, okay, is going to be x squared minus 2x plus 1 plus, okay, these two quantities. So I'm going to write this as 2x minus 4 times x minus 1. So that we can see if there are any zeros. Okay, so this is minus 4, sorry. We have 2x squared and x squared, so it's 3x squared. And our outer and inner terms here are going to be a negative 6x, and negative 2x is negative 8x. And my last terms here are positive 4 with a positive 1, so that's positive 5. And we can see if we can factor this. And we can. Luckily, this is prime. 3 is prime. And 5 is also prime. So if we put the 5 here, that means my outer and inner terms can be 3x and 5x. If they're both negative, it gives me negative 8x. Checks out to be a positive 5 at the end. So if I set these equal to 0, and I solve, I end up with x equaling 5/3 and x equaling 1. Okay, so we have a new table, like I was getting to before, with 3 intervals, and this will help answer about your points of intersection. So L, M, N. L is your intervals of x. That has not changed. Okay, and so we're going to do negative infinity to 1. 1 to 5/3, 5/3 to infinity. Okay, M is going to be the sign of y double prime. So if let's say I take something like 0 and I plug it into y double prime, I'm going to end up getting a negative times a negative, so that's positive. Okay? And if, let's say, I look at not 1 2/3, but 1 1/3, which would be in this interval, and I plug it in, so I end up with a negative number and a positive number, so that's negative when I multiply the two together. And then here I can take any number. I can even take 2. That's nice and easy. So this is going to be positive times positive, so it's positive. So what this tells us is about the concavity of y. And so the positive sign means it's concave up. You could put an arrow or right up. The negative means concave down, or you could write down. The arrow up, or you could put the word up. Some people actually write concave up. It's kind of putting it down twice, but that's okay. This leads us to O. So O is writing about the points of inflection. So y has 2 points of inflection. At x equals 1 and 5/3, because the sign of y prime changes. Doesn't matter if it changes from positive to negative or negative to positive. Okay, and P, again, turns out that there was no local max. And that was because y prime didn't change signs from positive to negative. Okay, and that's it. We're done. So that's your second derivative test. Good luck.